Limit of function. This time, we'll have to evaluate the limit of a given functions. We have 4 examples of finding the limit of function by the given value of x. So example number 1, we have limit of x minus 4 over x squared minus 7x plus 12 as x approaches to 4. So first thing we do is we have to substitute it first. So substitute first the denominator, which is numerator over x squared minus 7x plus 12. So substitute x is equal to 4. So numerator 4 squared minus 7 times 4 plus 12 equals numerator 4 squared equals 16 minus 28, 7 minus 4 plus 12. So numerator over 0. So which is, if the denominator is equal to 0, therefore it is undefined. So if the denominator is undefined, therefore the limit is not existing. So if the limit is not existing, in other words, we need to find another ways to make the function exist. So here we are. We have to factor it first, or factoring, which is limit x minus 4 over x squared minus 7x plus 12 as x approaches to 4. So we have to factor the denominator, which is 12 is equal, which is x squared minus 7x plus 12. 12, when you factor it, it is equal to negative 4 and negative 3. So therefore, x minus 4 over x minus 4 times x minus 3. So cancelled out. Therefore, the answer is 1 over x minus 3. So substitute x is equal to 4. So 1 over 4 minus 3. So the answer is 1 over 1, or equal to 1. So therefore, the limit is now existing. So we have another example. Example number 2. The limit of square root of x minus 6 minus 1 over 7 minus x as x approaches to 7. First thing we do is to substitute it first, the denominator, which is numerator is equal to 7 minus 7 because x is equal to 7. So therefore numerator is equal to 0. So this is undefined. So this will need other way to say that this limit is existing. So if ever you can see the square root or the radicals in your rational function, most likely you need to rationalize it first. So when rationalizing is not limited, you also rationalize the denominator as well as the numerator. So the numerator by multiplying the conjugate of the numerator. So this is the conjugate. The conjugate is the square root of x minus 6. So multiply both numerator and the denominator. So the square root of x minus 6 plus 1 over the square root of x minus 6 plus 1. So multiply it both numerator and denominator. So therefore, according to algebraic rule, a minus b times a plus b. So x times x is equal to square root of x times square root of x is equal to square root of x squared, or is equal to x. So therefore, the limit of a product is equal to the product of the limits. So to cancel the x minus 7, you need to define it first. So here is the negative and negative x plus 7. So now we can cancel out, which is, the answer is negative 1 over the square root of x minus 6 plus 1. So the limit of negative x over the square root of x minus 6 plus 1 as x approaches to 7 is equal to negative 1 over the square root of 7 minus 6 plus 1. So x is substitute by 7. So therefore, it is equals negative 1 over the square root of 1 plus 1. So square root of 1 is equal to 1 plus 1 is equal to 2. So negative 1 half over 2. Therefore, the answer is negative 1 half over 2. And now the limit is existing. And now let's proceed to example number 3, which is the limit of 1/4 plus 1 over x over 4 plus x as x is approaches to negative 4. So substitute numerator 4 plus x is equal to 4 minus 4 equals numerator over 0. So it is undefined. So in getting another way to make the limit of function exist, so we have to simplify complex fraction. So which is the limit of 1/4 plus 1 over x over 4 plus x as x approaches to negative 4. So first thing we do is you have to add the fraction. So you have to get the LCD, or the least common denominator of this. So it will be 4x. The LCD of 1/4 plus 1 over x is 4x. So therefore, 4x divided by 4 is equal to x times 1. So this is 1 times x. So 4x divided by x is equal to 1 times 4 over 4 plus x. So the answer of this is x plus 4 over 4x over 4 plus x. So therefore, in getting the answer of this, you have to make the reciprocal of 4 plus x, which is 1 over 4 plus x. So multiply it x plus 4 times 1 is equal to you kind of have to cancel this x plus 4 and 4 plus x, or x plus 4 is the same. So therefore the answer is 1 over 4x. So the limit, so substitution, the limit of this 1 over x as x approaches to negative 4 is equal to 1 over 1 minus 4 times negative 4. So it is equal to 1 over negative 16. So the answer is negative 1 over 16. Therefore, the limit is now existing. We have the last example of limit of function. So example number 4. We have the limit of square root of x plus 3 minus 1 over 2x squared minus 1 as x approaches to 1. So we'll substitute x equals to 1 sa numerator. 2 times 1 squared minus 1 is equal to n over 2 minus 1. So therefore, if we have to substitute the x minus 1, there is a limit existing. So if we're going to substitute the 1 to x, therefore the limit of 1 plus 3 minus 1 over, as we answer this, the answer is 1, so over 1 as x approaches to 1 equals square root of 1 plus 3 is equal to square root of 4 minus 1 over 1 equals square root of 4 is equal to 2 minus 1 over 1. Therefore, 2 minus 1 is equal to 1 over 1, or it is equal to 1. So therefore, limit is exist. So we don't need to find another way for this example. So thank you, and this is the techniques on evaluating limit functions. Here we are, another discussion, which is the properties of limits. So number one property is the limit of a sum, where the limit of a sum is equal to the sum of the limits. So its formula is limit of f of x plus g of x as x approaches to a. So we have two different limit function, which is the f of x and the g of x. So we're going to factor it. Limit of f of x as x approaches to a plus the limit of g of x as x approaches to a. So the example of this limit, limit of x plus 9 as x approaches to negative 4 is equal to limit of x as x approaches to negative 4 plus the limit of 9 is as x approaches to negative 4 is equal to, as we are going to substitute the x is equal to negative 4, therefore x is equal to negative 4 plus 9 equals negative 4 plus 9 is equal to 5. So 5 is the answer. So we have another property of limit, which is the limit of a difference. So we have the formula limit is equal to f of x minus g of x as x approaches to a. So we have two function, which is of f of x and g of x. So if we're going to factor it out, we have limit of f of x as x approaches to a is equal to limit of g of x as x approaches to a. We have another example. The limit of 12x as x approaches to 5 is equal to limit of 12 as x approaches to 5 minus the limit of x as x approaches to 5 is equal to, substitute 5 to x, 12 minus 5 is equal to 7. Therefore, the 7 is the answer. So, therefore, the limit of a difference is equal to the difference of the limits. Another property of limits, which is the limit of a product. So we have here the formula f of x times g of x as x approaches to a. So we have two function, which is f of x and g of x. So if we're going to factor it out, this will have limit of f of x as x approaches to a times the limit of g of x as x approaches to a. For example, the limit of negative 6 as x approaches to 5 is equal to the limit of negative 6 as x approaches to 5 times the limit of x as x approaches to 5. So equals negative 6 times 5 is equal to negative 30. Here another example. So the limit of 7x squared minus 4 as x approaches to negative 2 is equal to the limit of 7x squared minus 4. So we're going to factor it out, which is 7 times x minus 4 as x approaches to 2. So therefore, the limit of 7 approaches to x, as x approaches to -2 times the limit of x as x approaches to -2 times the limit of x as x approaches to -2 times the limit of -4 as x approaches to -2. So therefore, 7 times -2 times -2 minus 4. So -2 because we have to substitute the x, which is 2, -2, which is -2. So 7 times 4, which is 28, minus 4 is equal to 28 minus 4 is equal to 24. So 24 is the answer. So therefore, the limit of a product is equal to the product of the limits. So the last property we're going to take is all about the limit of a quotient. So the limit of a quotient is equal to the quotient of the limits, provided that the limit of the denominator is not equal to 0. So here is the formula of the limit of a quotient. So limit of a quotient limit is equal to f of x over g of x as x approaches to a is equal to limit of f of x as x approaches to a over the limit of g of x as x approaches to a is equal to limit of function over m, where m is not equal to 0. So that's all for the limits, the properties of limits. Thank you.